Now we are going to learn how the values of displacement, velocity and acceleration of the simple harmonic motion particle, that one varies from one position to another position when it is oscillating. Look at here, look at the tabular column. So here various timings are taken. Here I have taken the pendulum as the best example. So in this pendulum example, the total time taken by the pendulum to complete one oscillation is called time period. That is nothing but capital T. Are you clear? So you have to assume that the pendulum, it is at rest now. So when the pendulum, when it is in the equilibrium position, by the time the time T must be taken as 0. Are you clear? Just below to the pendulum diagram, I have drawn one circle. Already we have learned that the projection of the here, when the particle moves in the circular path, if you draw the projection, that one will give you the simple harmonic motion. So here the particle, when it is moving in the simple harmonic motion, that could be compared with the particle when it is moving in the circular path. So here the angular displacement of the circularly moving body can be measured here with the help of the circle. Its projection only, that one gives you the SHM, that is simple harmonic motion. So here angular displacement omega t is also given here. Are you clear? So first you assume that the pendulum, it is at rest, the circularly moving body, it is also at rest. This is the initial position. Now we will calculate the what are the displacement, velocity and acceleration values of the simple harmonic motion particle. First you substitute, so clear, here all the expressions are given. First you substitute omega t as 0 in the first expression. Now we can calculate the displacement. Where we are going to calculate the displacement? When the pendulum, when it is here, we are able to calculate the displacement. Instead of omega t, that is angular displacement is 0. With respect to this diagram, angular displacement is 0 and the time t is also 0. Substitute 0 here. Instead of omega t, substitute 0. When omega t is 0, sin 0, 0, therefore displacement will be 0. Where the displacement is 0? Here when the pendulum is at rest, the displacement will be 0. Are you clear? Now we are going to calculate the velocity. Let us imagine when the pendulum, when it is oscillating, whenever it crosses the mean position, we are going to calculate the velocity. Substitute the same omega t 0 value in the next expression. Cos omega t, instead of omega t, substitute 0. Cos 0, 1. Therefore, the velocity expression will be equal to, what is this? Plus a omega, plus a omega. This is called as velocity amplitude. This is the maximum velocity of the simple harmonic motion particle when it crosses the mean position. Whenever the particle crosses the mean position from negative direction to positive direction, whenever it crosses here, that particle will possess this much amount of maximum velocity. This is called as, what is this? Velocity amplitude. Now, in the same position, in the mean position, we are going to calculate the acceleration. Substitute omega t value as 0 here, sin 0, sin 0, 0. Therefore, acceleration will also be equal to 0. So, when displacement is 0, acceleration is also 0, but velocity, it attains the maximum value. So, like that, so clear, we have to substitute all the omega t value in all cases and we have to find out the value. Let's see the next one. So straight away I will substitute. Now the pendulum, so clear, when it is oscillating, it will reach this point. Are you clear? Let us imagine the pendulum, it has come here. So the circularly moving body, it may have come here. So what is the angle travel by the particle from here to there? This is equal to pi by 2, 90 degree. Are you clear? Here the pendulum, it reaches the right extreme end. Is it clear? In the right extreme end, we have to find out the displacement, velocity and acceleration of the simple harmonic motion particle. Here we can make use of this angular displacement with this help of this picture. Are you clear? So substitute now. So clear now. This 90 degree, sin 90 must be substituted. Instead of omega t, substitute sin 90 is equal to 1. Therefore, the displacement y is equal to a. This is nothing but amplitude. maximum displacement of the vibrating particle is y is equal to a. So when it reaches the right extreme, the total displacement, maximum displacement is amplitude. This is nothing but a. Let's come to the velocity. Cos 90 is clear. Instead of omega t, substitute 90. Cos 90 is 0. Therefore, velocity becomes 0. So whenever the pendulum, when it goes to the right extreme, and there it will take rest. Momentarily it will take rest. There momentarily it will be stopped. There the velocity will be 0. And let's calculate the acceleration in the right extreme end. Sin 90, instead of omega t, sin 90. Sin 90 value is 1. So therefore acceleration value will become minus a omega square. Are you clear? So acceleration, it reaches the maximum value. Acceleration, it reaches the maximum value in the right extreme end. Why minus sign? That acceleration will be pointing towards the negative direction, because acceleration, it tries to pull the particle towards negative direction. No, that's why negative symbol is given. A omega square is the maximum value of acceleration. Therefore this value is called acceleration amplitude. A omega square is called as, what is this? Acceleration amplitude. When displacement is maximum, acceleration is also maximum, but velocity is 0 in the right extreme end. Now the pendulum, it has come to the mean position. It has gone there. Now it is coming back to the mean position. Now it is traveling towards negative side. Now we'll see what are the corresponding displacement, velocity and acceleration. Substitute here. Sin, instead of omega t, substitute pi. Sin 180. Sin 180. Sin 180 value is 0. Therefore displacement is also 0. Are you clear? Here also sin omega t is there. Sin 180. So clear. Acceleration will also be equal to 0. Could you understand the concept? Now the same pi, so clear, that must be substituted here. Are you clear? That cos omega t expression, instead of omega t, substitute pi. Therefore cos 180. What is the value of cos 180? Cos 180 value is minus 1. Therefore after substituting minus 1, this value becomes minus a omega. What is the value? Minus a omega. So what it shows, when it crosses the mean position from there to here, the velocity value will be negative, because it is traveling towards the negative side, but it will have a maximum value. This is also called as velocity amplitude. Velocity will be maximum and it is trying to go towards which side? Negative side. Therefore this is the value of velocity when it crosses the mean position. Are you clear? Now we have found out all the three value when the omega t is pi. Let us imagine now the pendulum, that bob, it goes to the left extreme end. Are you clear? So when the pendulum is here, the total angular displacement must be taken as, what is the total angular displacement? Pi. Are you clear? Now the pendulum bob that goes here, the respective angular displacement must be taken as, what is this? 3 pi by 2. So clear, the total angular displacement must be taken as, what is this? 3 pi by 2. That is 270 degree. Are you clear? Now the bob, it has come to the left extreme end. Are you clear? Left extreme end. Now substitute that 270 degree, that is 3 pi by 2, that must be substituted here. Sin 270, sin 3 pi by 2 value is minus 1. Therefore minus 1 into a value is minus a. What that minus a indicates? So when the bob, it comes to the left extreme, here this distance is called minus a. That is negative amplitude is shown here. Maximum displacement of the vibrating particle is called amplitude, but the displacement is measured in the negative side. Therefore minus sign must be written. Are you clear? And then the same cos omega t, in this expression omega t value, instead of omega t substitute 270. Are you clear? Cos 270 value is 0. Therefore velocity value will be 0. So when it comes to this left extreme, momentarily it will be at rest. Velocity of the vibrating particle, oscillating particle will be 0. Are you clear? Now we will calculate the acceleration. Are you clear? Sin 270, sin 270 must be substituted. Sine 270 value is -1, already one minus is there, therefore that one becomes a omega square plus a omega square. What this a omega square indicates, when the pendulum, when it comes here, that one reaches the clear maximum displacement in the negative side, but acceleration value also reaches the maximum value, but acceleration is acting in the positive direction. That acceleration, it tries to pull the particle towards positive direction, therefore acceleration is acting towards the positive side, therefore positive a omega square is written. Now the pendulum, it has come to the same position, so it has traveled like this, it has gone to the left extreme, now it has come back to the same position. Now this circularly moving particle that can be brought here, because its projection, it is acting as simple harmonic motion. Now the total displacement of the circularly moving body is how much? 2 pi. Are you clear? Here it has come, it has it is completing one complete vibration. It takes t time. It has finished one oscillation. In the meantime, this particle, it completes one circular path. Are you clear? So the time taken by this body is t, and time taken by this simple harmonic motion particle is also t. Now when it comes to the mean position after the completion of one oscillation, what we have to do? Substitute here. 2 pi is the angular displacement. Substitute this 2 pi here. Sine 2 pi. Sine 2 pi value is 0. Therefore acceleration becomes 0. Are you clear? Cos 2 pi. Cos 2 pi value is how much? Cos 2 pi. You should know all sine curve, cos curve and tan curve. Is it clear? All the curves must be clearly understood. Only then there won't be any difficulty in finding the values. Are you clear? Cos 2 pi value is 1. Are you clear? So cos 2 pi value is 1, no? 1 into a omega is equal to a omega. Are you clear? Now velocity value becomes a omega. Are you clear? It can be taken as plus, because the velocity is acting in the positive direction. And then substitute sine 2 pi. Instead of omega t, substitute sine 2 pi. Sine 2 pi value is 0. Therefore acceleration factor becomes also 0. When displacement is 0, acceleration is also 0. Are you clear? Because displacement and acceleration both are directly proportional to one another. When these two factors are 0, this one will attain the maximum value. Are you clear? So these are all the clear values of the displacement, velocity, acceleration of the simple harmonic particle. So clear when it is attaining various positions. So very important one. So clear we are able to understand the complete dynamics of the particle when it is executing in the simple harmonic motion. Understood? Very important tabular column. With the help of this, we are able to understand so many concepts, so many things. Understood?